Hello, welcome to another short video of IQ in Motion. Today we're going to be talking about LEDs or light emitting diodes. LEDs are these little lamps that emit lights of different colors, and nowadays you can also get those in white. LEDs have two terminals, as you can see. They're called the anode and the cathode. For current to flow through them and for them to turn on, the anode has to be positive with respect to the cathode. The anode is usually the longer lead. To turn on an LED, we typically want about 10 milliamps to flow through them. The voltage on the LED for these 10 milliamp to flow, it's going to depend on the color of the LED. For red LEDs, it's going to be closer to 1.9 volts, and for blue LEDs, closer to 3 volts, with somewhere in between for green and yellow. So normally we do not connect LEDs directly to a voltage supply like 5 volts, for instance, on our project, but we connect that through a resistor. And we size that resistor so 10 milliamps will flow through the LED. The way we calculate that resistor is dividing the difference between the voltage supply and the voltage on the LED by 10 milliamps. In this example, we have a green LED, and if 2.3 volts is the voltage required on that LED for 10 milliamps, the resistor is going to be the difference between 5 and 2.3, which is 2.7 divided by the 10 milliamps, and that would be a 270 ohm resistor. For a blue LED, you would typically use a lower resistor, and for a red LED, a slightly larger resistor. Let's do an experiment to see how much voltage drops on a red LED. I have a red LED here that I'm going to plug in this circuit, and this meter is going to measure the current, and this meter is going to measure the voltage. So when I connect it here, the LED turns on, and I have 10 milliamps or 10.7 and 2 volts. Now, if I vary the voltage and the current, as you can see, the current varies to up to almost 13 milliamps, and the voltage barely moved at around 2.04. So if I lower again the current, the voltage still drops, but very little. Right, we're at 1.98 and less than 8 milliamps, 6 milliamps, all the way to 5 milliamps. We still have 1.93. So between 5 milliamps, at 5 milliamps we have 1.93 volts, and at 13 milliamps we have 2.04. So it varied at less than 0.1 volts when the current varied from 5 to 13 milliamps. So this works to an advantage for us to calculate resistors, because we know that pretty much any current that will be flowing through this LED is going to have a voltage of about 2 volts. Let's remove the red LED and install a blue LED instead. Okay. For the blue LED, and again I'm going to put the current back at 10 milliamps. So we have 2.84 volts. So like we said, this blue LED will take closer to 3 volts. And again, it doesn't vary a lot, right? So when the current is 12 milliamps, we have 2.87, and we can go down to 8 milliamps and we will still have 2.79. So the voltage varies very little with the current. And that is all for today. I hope you learned about LEDs, and we'll see you next time. Thank you.